Okay. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Let me introduce myself. My name is Fadhilah Oktaviyanti. My student identification number is 2113022025. I'm from Physics Education Department, class 21A. On this session, I will explain about heat and heat transfer. Okay. Heat. What is heat? Heat is energy in the form of heat that can move from a place with a higher temperature to a place with a lower temperature. Heat has the international unit joule or J. 1 calorie is the heat required by 1 gram of water to raise its temperature by 1 degree Celsius. Too much information. 1 calorie equals 4.184 joules equals 4.2 joule. And 1 joule equals 2.4 calories. Heat energy is defined as Q equals M times C times delta T, where Q is heat energy in joules or J, M is mass in kilograms, and T is change in temperature in Celsius. Okay. Next is specific heat and heat capacity. Specific heat is the amount of heat required by 1 kilogram of a substance to raise or lower its temperature by 1 degree Celsius or 1 Kelvin. Specific heat can be defined as C equals Q divided by M times delta T. And then heat capacity. Well, the heat capacity is the ability of an object to receive or release heat so that it increase or decrease the temperature of the object by 1 degree Celsius or 1 Kelvin. Heat capacity can be defined as C capital, equals M times C, where C is the specific heat of the object, so it can also be defined as C is equals Q divided by delta T. Okay. The next is Black principle. The Black principle explains the law of conservation of heat energy. If two objects with different temperatures touch each other, heat will flow from the object with the higher temperature to the object with the lower temperature, thus achieving thermal equilibrium. The Black principle applies when the system is isolated, meaning that no heat enters or leaves the system. The equation for the conservation of heat energy according to Black principle is heat free or Q free equals heat accept or Q accept. Okay, next. Fourth is change in the state of matter. Change in the state of matter are affected by heat energy. The following are state change in physics, namely, first, sublimation. Sublimation is change of state of matter from solid to a gas. Second is deposition or crystallization. Deposition is change of state of matter from gas to a solid. Third is melting. Melting is the change of state of matter from solid to a liquid. And fourth is freezing. Freezing is the change of an object from a liquid to a solid. And 5 is condensation. Condensation is change of state from gas to liquid. And last is evaporation. Evaporation is the change of state of a substance from a liquid to gas. To change the temperature of substance requires as much heat energy as Q equals M times C times delta T. And to change the state of a substance requires as much heat energy as Q equals M times L, or Q equals M times U, where M is the mass of the object in kilograms, L is the latent or heat of fusion with unit of joule per kilogram, and U is the heat of steam with units of joule per kilogram. Second submaterial is heat transfer. There are three types of heat transfer, namely conduction, second is convection, and third is radiation. First, I will explain about conduction. Conduction is the process of heat transfer without being followed by a transfer. For example, you can look to the picture. This is a spoon that is held will feel hot if one end is heat. The amount of heat transferred per unit time is shown by the following equation. H equals Q divided by T equals K times A times delta T divided by L. With K is thermal conductivity of the material, H is heat transfer rate, A is cross-sectional area in meters squared, T is system temperature difference in Kelvin or Celsius, and L is length or rod or system, and Q is heat in joule, and T is time in second. Okay. The second is convection. Convection is the transfer of heat accompanied by the movement of constant particles. For example, you can look to the picture. This is boiling water. This water cools become more dense things, and this is convection current, and this is hot less dense water rise. The rate of heat flowing in a substance follows the following equation. Is H capital is convection equals Q divided by T equals H small times A times delta T, with H small, this is convection constant. Okay, the last type is radiation. Radiation is the transfer of heat in the form of electromagnetic waves. Example of heat transfer by radiation is solar radiation, blue light radiation, and lamp radiation. Radiance heat rate is shown by the equation W equals sigma times T to the power of 4. And the energy emitted per unit time is defined as H equals Q divided by T equals sigma times A times T to the power of 4. And then the energy emitted for any type of surface object can be defined as H equals Q divided by T equals E times sigma times A times T to the power of 4, with sigma is Boltzmann constant equals 5.5 multiplied 10 to the power of minus 8. Okay. Next is the example. I have one example. 2 kilograms of water at 40 degrees Celsius will be heated to 70 degrees Celsius if the specific heat of water is 4.186 joule per kilogram Celsius. How much heat is absorbed by the water? The answer or the solution. From this question, it can be seen that the mass is 2 kilograms and C or a specific color is 4.186 joule per kilogram Celsius. T1 or initial temperature is 40 degrees Celsius and T2 or final temperature is 70 degrees Celsius. How the heat? Okay, first find the difference in water temperature. Delta T equals final temperature minus initial temperature equals 70 Celsius minus 40 Celsius equals 30 Celsius. Okay, after that, find the heat using the equation Q equals M times C times delta T. And the result is 205 C 1160 joule. Okay. That's all from me. Thank you and wassalamualaikum warahmatullahi wabarakatuh.